So this is what we will do. We've been working on these grids. So if I put an X and I'm going to put 1, 2, and 3. Now there are quicker ways to do that by using these arrows up here. This is the paste function. This is a move thing. So, but what I'm going to do now is down this side, I'm going to put another X, and I'm going to put. So I've got a 1 there, and with the 1 selected, I'm just going to press down 2, 3, 4. Makes it quicker. All right. So I've got X plus 3 times X plus 4, and I'm going to do the expansion. So how do I expand it? Well, what is in this gap here? So there's an X squared here, so we can move the blue square there. What goes here? Well, we're going to do X times 1 3 times. So it's going to be, put an X, copy, copy. And then I'm going to put down here, copy, copy. Okay. Remember at all times, I'm asking you to think about why do you add and multiply the two numbers. Now, in this case, 1 times 1 gives you 1. So we've got 3 of those, and then we can go down. Don't think you can do anything. And then down. Okay. So basically then, the answer to x plus 3 times x plus 4 is an x squared. 4x's plus 3x's is 7x's. Hopefully that'll explain why plus 7 without an x is wrong. And then we've got 12 ones. Okay? All right. Now, you are going to do a little bit of exploration for yourself. So if I sort of go back to this, what do you think the red?
Oh,
Minuses, good. All right. Now, what you're going to do, so you can use the algebra tiles, but you are going to do a bit of, well, you've got a question to answer, which is, if you can kind of get it, why do we add and multiply? That's one question. Okay. So what you're going to do is do your diagrams. You can do them on the computer, but I think it'd be good if you did little sketches in your book to some extent. So we did x plus 3 times x plus 4. So we kind of had an x, a 1, like, well, probably easy just to say x plus 3, and then we've got x plus 4. So what did we have? X times x gave us a x squared. X times the 3 gave us 3x's, plus of them. X times the 4 gave me plus 4x. And 4 times the 3 gave me plus 12. Okay? So can you see how this grid matches the algebra tiles? Okay.
The grid's easier. So.
Yeah, eventually. Yeah, it might even already be easy. Yeah, but I'd like you to, at least for now, to kind of appreciate where it's coming. That's a times symbol to say if you do a multiplication. It's just a basic multiplication grid. Yeah. So what would it have been? So this one would have been the blue. Okay, this would have all been yellows, and these would have been the greens for the x's, yeah? All right, so just have a go at, and I'm going to get you to pick some of your own. Maybe as partners say, well, I'm going to give you one, this is what I think it is, do the diagram. So look at what's x plus 2, what would x minus 4 look like? Do a few, but ideally what you're going to then look at is, well, can we extend that to what will happen if I do 2x plus 3 times 3x plus 1? What do you think that will look like? Now, some of you will get to... Do you want to move? One of you move. Yeah, well, I don't know why you're laughing, because so you're being distracted. So you're going to look at that. How would you... I'm waiting. You're right. Move. All right. So ideally, you'll get to the stage where you can expand, and then we'll probably have to look at how, when we go the reverse of this, but the expansion bit is the first bit. I'll pause it. If I did 2x plus 3 times, what was it? 3x. I'm going to struggle to fit, but you can have a think what you think it would be. So a bit of an investment. Now, some of you might say you don't want to use the algebra tiles. You might want to do the other grid method, but the idea is to think, right. So I'm going to be happy, by the way, if you say to me, I've tried this one, can you just check my answer? That's fine, because you're coming up with your own idea and you just want to know. Ask the person next to you whether they think that's right, probably before me.
So is the title going to be why do you add and
Yeah, that's ideally what you are going to be able to answer is why do we add and multiply? And I guess, do we always just add and multiply? I've already said yes. Do we always add and multiply? Don't forget you got work to catch up on. That'll be a video. All right. Okay, over to you. So you've got that program on your devices if you wish. If it helps. Do you turn up really late and help disrupt? Right? You can open the lines if you like. Do you think that would warm you up now? But
what's that? It's like a chair thing. Where's that?
you don't need the class lead.
2 days. Yeah. Makeup 2024 onwards. Good job. There's no job feature.
I'm saying.
No more. Yeah. Yeah.
You all right?
I'll rotate you.
Worst case scenario, just redo the one I just did and think, do you understand what's happening?
No. Are we just taking a random?
Yeah. Make one of your own. Come up with your own.
I really understand it.
And so what we're trying to do, so basically what I am hopefully going to be able to do in your next assessment is so if I say expand and I give you something like x plus 4 times x minus 6, can you do it? So what I'm doing, I don't need the answer. I'm just like,
What would it be like that?
so you are going to have what I'm trying to get to is like, so we've got a pattern, we've spotted a pattern. It's the add and subtract. I just want to know, so you will have a much deeper understanding if you can get, this is why I add and subtract. Yes.
Sure, expand the one you put it into the thing we're doing here. Right?
Exactly. So if I expand that, so it's going to be x squared
Yeah, plus
minus 2x
yeah.
minus 24.
So what's the other one called when you put it in?
Okay, good
4x?
question. So if I said the other way, I would do what's called factorize x squared plus 7x plus 12. That's what we did. Okay.
So is that what they think?
Well, this one we went from that to that, but this one we would go from that back
Oh,
to.
no. So, I mean, yeah, I get that.
Yeah.
I mean, what would be if you go x?
Yeah.
4 plus 4x times negative 6x.
Oh, that's just expanding. That's the process of expanding.
Oh.
What,
After.
ideally, what I'm after is hopefully all of you will be able to do the expanding.
Yeah, that's.
Yeah, all of you will be able to do the expanding. What I'm hoping is that the majority of you will have a little bit of a deeper, like why you're doing what you're doing, and you'll develop your own understanding of the approach by looking at these diagrams. So by thinking about why do I add and subtract, because the reason is expanding is always quite easy. So if I said expand 2x plus 1 at times, no, what was it? 2x plus what? 3 and 3x plus 1. Most people can expand that, fine. But if I said to factorize 5x squared minus 10x plus 5, for instance,
Yeah.
a lot of people, no, I don't even know whether that's going to work, but a lot of people really struggle with that. And I want to get to that point because you will understand what you're doing.
So if you don't need to add the x in the brackets.
So what have I done? Stop.
You
I
don't
mean,
need to add.
I don't understand any of this. Why are we using this box?
So I want you to
Like, what is the box meant to represent?
Well, you don't need to add the x.
That looks alright. Is it just they choose it to do
You tell me. Ask you to consider. Instead of thinking in terms of I did have a think. Just actually happening. So, well, negative 1 times x is actually actually all of it. No, those two in your bracket.
That's very good. Who are you playing for?
So,
Ooh, the Western boys. Wait, I'm not. There's Wilson for the play. Wilson. Sir, can you explain what? Actually, you're gonna Jack. It's asking. It's about all those.
shoot one.
You can be wrong.
Yeah, that's fine. You've got 6x squareds. You've got 6x squareds. You've got 3, 6, 9 x's. X plus 3, 3, 6, 9, 10, 11. He's got 9 and 2 makes 11. And you've got a plus 3, he's got a plus 3. You've got exactly the same thing.
But what if I prefer to do this?
So that's the
Weird. You get it? Yeah, sure.
Jason is Jason idea.
Can you help with?
Or that could be a yeah.
I can something.
Should that? Yeah, you do. Let's do this. Wait, I'm with a patient right now.
Okay, gents. Let's do this together a little bit. Let's do this together. You watching? Is everyone together with me? Oh, it was still recording. Let me. What I'm going to do is I'm going to do something. Work backwards a little bit. It might help. So let's say I've got x squared. Okay. I've got 3 x's. Okay. And I've got 2. Okay, so just to put that in here, and so this hopefully might explain what I'm talking about. Okay, so I think it will. So on a diagram, I've got, this is the diagram. What this is, have you created that on yours as well? So I've got an x squared, I've got 3 x's, and I've got plus 2. Make sure you watch the video, yeah? All right, have you done it, guys? Have you created your x squared plus 3x plus 2?
No.
What I want to do is to figure out what the 2 brackets are. Are you with me, Javier? Yeah? You sure? Okay. So what I want to do is I need to figure out what times what gives me all of this. Okay? So I need to rearrange this to make a rectangle. All right? Because when we multiply one thing by another, the results will look like a rectangle, yeah? So any ideas how I could rearrange this? So I can see this already. And this is what you can tell. So I'm going to split this up. I'm going to rotate that and I'm going to put it there. So the 2's, is everyone watching what I'm doing? Because obviously you're going to ask me some more questions later and I'm going to go, I did that. So can you see it's a rectangle now? Okay. So how did I get that? Well, an x times an x gives me the x squared. 1 times an x gives me the x. A 1 times the x gives me this x, and another 1. So what are the brackets? It's going to be x plus 1 times x plus 2. Okay? So if I go back to my working, so I know, do you remember how you said it? It was like, well, it's going to be x plus 1 times x plus 2, because 1 plus 2 makes the 3, and 1 times 2 makes the 2. Okay? All right. What one? These ones? Well, that's the start question. So this is what we're going. This is called. So for your notes, we'll start to introduce these things now. This is the standard form of the expression. This one is called factorized form. There's lots of people not writing this down, by the way, which is. Okay, let's try one more. Let's show how we would do x squared. Okay. Let's do plus 8x plus, what could the number be on the end? Someone else give me. 10?
Oh, so, no, 16.
16?
Yeah.
Why 16? Okay. So x squared plus 8x plus 16. So if we were, well, you are now. Have you written that down? X squared plus 8x plus 16. Okay. What we're now going to do is go to your algebra tiles. Let's tidy it up. We are going to put x squared. We had 1, 2, 3, 4, 5, 6, 7, 8. And then we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. So we've got 1x squared, 8 x's, and 16 ones. Now, what you are going to figure out is how you can rearrange. It should be quite quick and simple, actually. You're going to figure out how you can rearrange that to make a rectangle so that you've got something times something to make the grid. That makes sense? So have a go quickly yourself. You've got little things like, if you want, obviously, some of these are going to have to be rotated, so you can rotate. Click the rotate button. So, right, Ollie, explain what you did. What was you thinking? Everyone with us? No? So if I rotate and put 4 underneath, so I'm going to have, if everyone's doing this with me, then you'll have the example. So 4 underneath, and 4 and 4 on the, why is it doing that? Doesn't matter. And then I've got 4 on the sides.
The ones.
And then I can rearrange the ones to fill the gap. So 1, 2, 3, 4,
Sorry, you realize you can just like do it
Hey?
do it the slow way.
Yeah, I'm doing it the slow way so you can see what's going on. I also think my mouse is a bit dodgy at the moment. You should be able to do it. There you go. No, it's still not doing it. Okay, what does that make the brackets then? So we've got that diagram goes together with this expression. So that's the standard form. What would the factorized form be? Max? So x plus 4 times x plus 4, because 4 times 4 makes 16 and 4 plus 4. But you can see it on here. Look, if this was an x on this side, this would be 1, 1, 1, and 1 to make 4 x's. So that would be x plus 4 on the top. Down here, this length is an x, and then I've got 1, 1, 1, 1. So that would be 4. So I'd have an x plus 4 down the side. Now, some of you are wanting to go straight to the grid method. So if I wanted to expand x plus 4 and x plus 4 using this method, hopefully you're now getting that x times x is x squared. Then I've got 4 lots of the x is 4 x's. Another 4 lots of the x is 4x. And here it's 16. Okay? All right. Now, let me ask you this to get you creating your own problem. All right? I'm going to say I want a 2x squared plus something plus something. Okay? Now, use your algebra tiles, the computer program. You come up with a 2x squared plus so many x's plus a number that would work in 2 sets of brackets. So what I mean by that is you can lay it out as a rectangle. Okay? Just come up with one for yourself. So a 2x squared plus something else. So what I'd be doing, guys, is on your algebra tiles. Not today, because it's Monday.
But is there any due tomorrow?
All right, so what I'll do here, guys, is I'm going to start by laying out my 2x squareds. So, I need some x's and some 1's. What would you do? What expression did he create? So I've got the 2x squared, so that's what I asked for. What's the middle term? Max? 9x. And then plus 9. Now I've got a question for you. Why did you add the 2 numbers and multiply? Now let's look at what this expansion was. So this should be what's in the first brackets. Up here I've got an x, and a 3. So it's going to be 2x plus 3 times x 3. So x plus 3. Now let me ask you then. Do we add 3 and 3 to make 9?
I feel like it's a trick question. It's kind of the way you said it.
Well, obviously, you can answer that very quickly. Do be careful. Do not add 3 and 3 to
No.
make 9.
No.
No, you do not add. So, do you remember that pattern that we've been using where we say those two numbers added together make the middle number when you add them, and those two numbers when you multiply make the end number? Has that stayed true in this
No.
case?
No.
Alfie, so I've just used your name on video because you're not paying attention. So that's YouTube immortalization. Okay? All right. I want you, hopefully you've seen this one now then, which is 2x squared. So I'm going to get you to do another one for me. I'm going to get you to show me what a 3x squared plus something x plus something could be, please. So come up with another one for me, please. So I want a 3x squared plus something plus something. So we've got 3x squared plus 12x plus 9. Another option would be if I just went, if I deleted the bottom row, I think. That would therefore be 3x squared plus 9x plus 6. If I deleted another row, what would that be? 3x squared plus 6x plus 3. Now, just to finish us off, this has been a tough one. I can see it in the way you're all. It's been making you think, which is a good thing. All right. Hey? Yeah, it is. All right. Come on, guys. Stay with me literally for the last minute. So the one I've just done is, Rafe, talk to me. 3x squared plus...
Oh.
So how many x's do I have? 1, 2, 3, 4, 5, 6. So 6 x's plus 3. So what's the factorized form when it's in the brackets? So
3x
3x plus 3. Good.
Oh, yeah, 3.
And then on this side, it's just 1x plus 1.
I get 6.
You do 3 plus 3.
Oh, yeah, got it.
Yeah. Because 1x times 1x gives you x squared. 1x times 1 gives you an x. 3 times 1 gives you 3. Okay.